So in part 1 of this video, we have find the energy of electron in nth orbit, and it was En is equal to minus 2 pi square m k square z square E4 upon n square h square. Here the negative sign indicates that electron is bound to the nucleus because of the electrostatic attraction force between electron and nucleus, that is negative and positive, and there is some work required if you want to pull that electron away from the nucleus. Okay, so according to Bohr's theory, we get this much value of energy of electron in nth orbit. Now according to Bohr's frequency condition, we know that according to Bohr's frequency condition, the photon that is emitted by the electron or absorbed by the electron when it transits from one energy level to another, that photon has energy equal to the difference between those energy levels. That is, if there is an electron revolving in this orbit and it come to some inner orbit, it show a transition like this, means this is the nucleus and electron is in the outer orbit and it transit to the inner orbit. So during this transition we get a photon, and that photon has the energy which is equal to the energy difference between these two energy levels. So if we have these orbits as, this is orbit number 1 like n1 or 1, this is orbit number 2 means n2. So I am considering that n1 is the lower energy level, n1 is lower energy level and n2 is higher energy level, and a transition is happening from n2 to n1. So electron is transiting from n2, that is the higher energy, to the lower energy, and during this transition it will emit a photon. During this transition it will emit a photon of energy h nu, whose energy is equal to the difference between the energy of higher level and lower level. So this energy h nu of the photon is equal to the energy difference E2 minus E1. E2 is the energy of higher energy level, that is n2 level का energy है, and E1 is the energy of lower energy level, that is n1. So we can write this h nu is equal to E2, which corresponds to the value of n2, energy of orbit n2. So we can write the value, this En2 is equal to minus 2 pi square m k square z square E4 upon n2 square h square, again minus 2 pi square m k square z square E4 upon n1 square h square. Now in case of hydrogen, for hydrogen this z is equal to 1, so we are going to put the value of z is equal to 1 in this formula, and we get h nu is equal to this minus 2 pi square m k square E4 upon n2 square h square, and this minus minus plus, and 2 pi square m k square E4 upon n1 square h square. Now if we take common from this, we get h nu is equal to 2 pi square m k square E4 upon h square, and within the bracket it is 1 upon n1 square, which is positive, minus 1 upon n2 square, which is negative. So this is the relation we get for h nu, which implies the frequency of that radiation or that photon which we are getting, which is emitted during the transition, is nu is equal to 2 pi square m k square E4 upon h cube, right, into 1 upon n1 square minus 1 upon n2 square. This is the frequency of that photon that we are getting. Now since we know that the speed of that photon is given as frequency into wavelength, and the wave number is given as 1 upon wavelength. So we can write wave number which is equal to reciprocal of the wavelength and is given as nu bar. So nu bar is the wave number, right? This nu bar is equal to wave number and is equal to 1 upon lambda, and this 1 upon lambda is equal to 1 upon c upon nu, means lambda is equal to hota hai c upon nu, which implies this 1 upon lambda is equal to nu upon c, and the value of nu is here. So we are going to put this value in this equation. That means we will get 1 upon lambda is equal to 2 pi square m k square e4 h cube upon h cube. This is for nu, and upon me we have c. So this is c, and the value is here in the bracket 1 upon n1 square minus 1 upon n2 square. So we just substitute the value of nu in this equation and we get wave number. So the wave number nu bar is equal to 1 upon lambda is equal to this, and the value for nu bar is, this is the value for nu bar that we get. So the wave number nu bar is equal to 1 upon lambda is equal to capital R 1 upon n1 square minus 1 upon n2 square. Now here capital R is this constant, right? Capital R is this constant, and we call this constant as Rydberg constant. This constant is called Rydberg constant, and its value is 1.0973 into 10 to the power 7 meter inverse. So this is the value of Rydberg constant, right? This is denoted by R and is known as Rydberg constant, and its value is 1.0973 into 10 to the power 7 meter inverse. Okay, so finally we get the equation for the photon that is emitting. For that, wave number nu bar is equal to R 1 upon n1 square minus 1 upon n2 square, where R is Rydberg constant, n1 is lower energy level and n2 is upper energy level. This we have. Now the origin of various series, spectrum series in the hydrogen spectrum can be explained by using this relation. So that is the advantage of Bohr's model, that we can explain spectral series by using the results of Bohr's model. So we are going to explain the origin of various series in hydrogen spectrum. So we have 5 kinds of spectral series. First is Lyman series. Then second is Balmer series. Third is Lyman, Balmer, Paschen. Fourth, Brackett. And the last one, that is the fifth one, it is Pfund. We write it as P Pfund, but we pronounce it as Pfund series. So these are the 5 spectral series that we get during study of hydrogen spectrum. Let's start with the first one. So whenever electron jumps from higher levels to first energy level, right, means the lower energy level is fixed, that is n1 is equal to 1, and n2 can be 2, 3, 4 and so on. So if electron jumps from higher energy levels to first energy level, in that case we get this equation, nu bar is equal to 1 upon lambda is equal to R 1 upon 1 square minus 1 upon n2 square, where n2 is equal to 2, 3, 4 and so on. And this equation represents the series that we get during the transition from higher level to the first level, and we call this series as Lyman series. So we get Lyman series when electrons from higher energy levels jump to the first energy level, and the series that we get during this transition is belong to the ultraviolet region. So this series belong to ultraviolet region of electromagnetic spectrum. Similarly, in case of Balmer series, the spectral series corresponds to the transition from higher levels to the second energy level. That means for Balmer series, N1 is equal to 2 and N2 can be any higher level above 2, that is 3, 4, 5 and so on. So for this, the equation nu bar is equal to 1 upon lambda is equal to r 1 upon 2 square minus 1 upon n2 square, and in this case the series we get, it lie in the visible region. So Balmer series that we get, it lie in the visible region. Lyman was in ultraviolet region and Balmer is in visible region. Now in case of Paschen series, N1 is equal to 3 and N2 is equal to above 3, that means 4, 5, 6 and so on. So if electron transit from higher energy levels to the third energy level, in that case we get Paschen series, and that series belongs to the infrared region. So for Paschen series, nu bar is equal to 1 upon lambda is equal to r 1 upon 3 square minus 1 upon n2 square, and it belongs to infrared region. For bracket series, electron transit from higher energy levels to fourth energy level, and so on, and for it nu bar is equal to 1 upon lambda is equal to r 1 upon 4 square minus 1 upon n2 square, and the series that we get, it lie again in infrared region. So bracket series also lie in infrared region. For Pfund series, the lower energy level on which electron transit is N1 is equal to 5, and it transit from higher energy levels from 6, 7, 8 and so on, either from 6 or 7 or 8 it will transit to level number 5. In that case, nu bar is equal to 1 upon lambda is equal to r 1 upon 5 square minus 1 upon n2 square, and the series that belongs to this Pfund series is belongs to the region called infrared region again. So Pfund series also belongs to infrared region. So the most important achievement of Bohr's theory is that it explained the hydrogen spectrum series, जो इससे पहले किसी से भी explain नहीं हुआ था. That was explained by Bohr's theory. So this is one of the great achievement at that time, because no one knows how we are getting these lines, and Bohr theory is explaining it accurately. So that's how these series are originated, that we are getting in energy spectrum. Now since we know about the series, now let's talk about the energy levels of hydrogen atom. So in case of hydrogen atom, the energy of nth level that we have find, we get this energy En is equal to, this energy En is equal to minus 2 pi square m k square. Now z is equal to 1, so I am not writing z square, it's E4 upon n square h square. Z is equal to 1 for hydrogen atom. If we are talking about hydrogen specifically, then z is equal to 1. So this is the energy for nth orbit. Now if I want to find energy for the first orbit, that means for n is equal to 1, means the energy of electron if it is revolving in first orbit, then we call it as E1. So that will be minus 2 pi square m k square E4 upon 1 square h square, right? Now this value 2 pi square m k square E4, this is all constant. So let's put these values. Minus 2 pi is 3.14 square, mass is 9.0 0.11 into 10 to the power minus 31. K is 9 into 10 to the power 9 square, and E is 1.6 into 10 to the power minus 19 power 4, right, upon Planck's constant is 6.63 into 10 to the power minus 34 ka square, and this is 1 square. So if we solve all these constants, we get minus 13.6 upon 1 square electron volt, right. First we get the answer in joule, and then we convert it into electron volts, and the final answer we get is minus 13.6 upon 1 square eV. To convert that joule answer into electron volt, we have to divide it by 1.6 into 10 to the power minus 19. So the answer we get will be in joule, and we divide it by 1.6 into 10 to the power minus 19, then the answer, final answer we get will be in electron volt, and it will be equal to minus 13.6 upon 1 square. Now also we can write the energy En in this term. So En will be equal to minus 2 pi square m k square E4 upon n square h square, and this whole term is minus 13.6 eV, right. So this is minus 13.6 upon n square eV. So now we have an easier relation for finding the value of energy of different orbits. For n is equal to 1, we just have to put 1 on the place of n. That means E1 is equal to minus 13.6 1 square eV, that is minus 13.6 eV. Similarly, for n is equal to 2, E2 is equal to minus 13.62 square eV, that means minus 13.6 upon 4, which is equal to minus 3.4 eV. Similarly, for n is equal to 3, E3 is equal to minus 13.6 upon 3 square eV, and it is equal to minus 1.51 eV, and so on, and the process go on like this. So we can find energy of any orbit. Since an electron can have only definite values of energy, means in first orbit it has energy minus 13.6 eV, after that it will exist in first orbit, or after that it will exist in second orbit. So in second orbit it has this particular value minus 3.4 eV. Now the values between this range cannot be occupied by the electron. That means electron have only certain definite values of energy when it revolves in different orbit, and this is called energy quantization. Now since electron can possess definite certain amount of energy, when it moves in different orbits, so the energy is quantized, or we call it as energy quantization, right. Means the energy is discrete, that is called the energy is quantized, or we call it as energy quantization. Now we can also show these spectral series at different energy levels. How we get spectral series when electron transit from different energy levels to different energy level, that we can show by using a diagram called energy level diagram. So now I am going to plot energy level diagram for hydrogen atom. So for that, first we form different energy levels with energy E1, E2, E3 and so on, and then we'll show the transition of electrons. So here in the diagram we have energy level diagram for hydrogen atom. Now since we know that whenever electron transit from higher energy level to first energy level, so this is first energy level, and electrons from higher energy level when transit from higher energy to this first energy level, the radiation they will emit will come under Lyman series. Okay. Similarly, when electron transit from higher energy levels to second energy level. In that case, the series we get will be Balmer series, and if it transit from higher to third, we get a photon of Paschen series. If it transit from higher to fourth energy level, we get a series called bracket series, and if it transit from higher to fifth energy level, then we call it as Pfund series, and so on. So process go like this. Now Lyman series come under the category of ultraviolet region, so the photon that we get will be of ultraviolet region. In Balmer we get visible light, it comes under visible region, and these three, Paschen, bracket and Pfund, in all the three cases we get the photon of infrared region. So this we have to remember. One more point we have to remember is, if we see the energies of these level, then we have the formula for nth, it is minus 13.6 upon n square, and by using this formula we can find the energy of all these levels. And if we see the difference between these energies, so it is decreasing, the difference between these energy levels is decreasing. That means as the number of level is increasing, as we are going to more and more higher levels, these energy levels are coming near to each other, the difference between them is reducing and they are coming near to each other, and after a certain level, these, after a certain point, these will appear as continuous energy level to us. Okay, so these discreteness will be lost if we talk about very high energy levels. Very high energy levels के बारे में अगर हम बात करेंगे, then it will seem like continuous energy band instead of level. So this is the energy level diagram for hydrogen atom, which show all the 5 kind of series: Lyman, Balmer, Paschen, bracket and Pfund. So that's what Bohr model explained. So the basic advantage or good thing in Bohr's model is that it can explain this spectra that we are getting practically and was not explained by Rutherford's model. Now there are still certain limitations to Bohr theory also. So these limitations of Bohr model are that it is only applicable to single electron atoms like hydrogen. If there are 2 or more electrons present in the atom, then this Bohr theory can't explain it exactly or accurately. So it is applicable for those atoms which has single electron only. Second thing, it couldn't explain fine structure, as some of the lines that we are getting in the spectra are in groups, there is not a single line, then this existence of this group of spectral lines was not explained by the Bohr's model. Next thing is, in Bohr's model he chose circular orbits, so it can't explain why circular orbits and why not the orbit should be elliptical. So this was also not explained by the Bohr model. And the last thing is, it can't explain Zeeman and Stark effect. Zeeman effect and Stark effect are, Zeeman effect is the spectral lines that we get during the practical is show splitting if we apply magnetic field. So Zeeman effect is basically splitting of spectral lines. Zeeman effect is splitting of spectral lines in the presence of magnetic field. Similarly, Stark effect is splitting of spectral lines, but the difference is this happen in the presence of electric field. So these two effects were not explained by the Bohr model. So these are the limitations of Bohr model. Rest, it explains the stability, it explains the spectra of hydrogen atom. That is the good point if we consider Bohr model as true. Okay, so that's all for the Bohr's model. For further topics, stay tuned and keep studying. Thank you.